Alright, welcome back to example 2 under directional derivative. So in the previous part, we looked at the formula to calculate the directional derivative and the application of it, where we looked at one example. So here is a second example we are going to be using to explain the concept of directional derivative. Alright, so the question says, find the directional derivative of the function. The function is represented as phi, which is given as x squared z plus 2xy squared plus yz squared at point 1, 2, and minus 1 in the direction of the vector A equals to 2i plus 3j minus 4k. Alright, so let's do this. So if you watch the previous example, I want to believe you won't have problem solving this. So just to test your understanding, you can just pause the video, attempt this question with the knowledge of the previous example, and then just take note of your answer. And then let me know in the comment at the end of this solution if truly you got it before seeing the solution. And if you missed the previous parts, I'll just encourage you to just check the playlist on engineering analysis. You're going to find the link to the video there. Alright, so let's get started into this. Again, the formula is giving us, so for directional derivative, so it's giving us, so like I said, let's bring the A first. So A and the dot product of delta phi, which is grad phi. So now let's calculate for the grad of the function. Again, the formula is giving us as this. So let's just look for each of those values. So starting with partial differential of phi Alright, so if you have to differentiate, if you have to look for the partial differentiation of the function with respect to x, so that will give us 2xz. So 2xz from this, 2xz, and then this will be 2y squared, and then this will be 0. So let's go ahead and write it down. So if you have to look for the partial differentiation, that will be 2xz plus 2y squared. So for this, it will be 0 because we don't have x there. So let's go ahead and write that down. So that will be 2x, like I said, 2xz plus 2y squared. Okay, so let's do that of y. So for that of y, so for this, since there is no y, this will be 0. And then for this will be 2, that will be 4. 4xy plus z squared. So let's go ahead and put that 2 down. So that's 4xy plus z squared. So let's do that of z. Okay, so for that of z, this would be x squared, this will be 0, and this will be 2xy. Okay, so like I said, I want to believe by now, if you have been following from the beginning of this lecture series, you won't have problem with looking for the partial differentiation of some of these values. Alright, so having gotten this, now let's look for what the value will be at when x and y and z is equals to, let's go back to the question. So from the question here, at point x is equals to 1, y is equals to 2, and then z is equals to minus 1. So let's put in some of those values here. Alright, so at point x, y, and z, this is going to be 2 times our x is 1, and then our z is minus 1, plus 2 times y is 2, so 2 squared will be 4. So with this now, so I forgot to add, this would be I, j, and then this would be k. So this would be 2 minus 2 plus 8, and then this should give us 6i, and then this will give us 4 times x is 1 and 2 plus z squared is 1. So this will be 4 times 2, 8 plus 1, and this will give us 9j. Then this is x squared is 1, so there will be 1 squared plus 2 times 2 times minus 1. So this will be 1 minus 4. So this will be minus 3k. So that's minus 3k. Alright, so now we've gotten the grad phi to be equals to 6i plus 9j minus 3k. So we've gotten that. So now let's calculate for a, and our a is capital A over the magnitude of a. Alright, so from the question, let's see what our a is. That's 2i, this is it, 2i plus 3j minus 4k. So 2i minus 3j plus 4k. I hope I got that. 2i plus 3j, is it minus or plus? Oh yeah, plus 3j. Are we good? Alright, so so this is our a. So the magnitude of a will be square root of 2 square plus 3 square plus 4 square. Alright, so that's similar to having 2 square is 4 plus 9 plus 16. So let's see what that value will be. So 4 plus 9 plus 16, that will give us 29. Alright. So with this now, we already know that our a, small a, is 1 over root 29 multiplied by 2i plus 3j plus 4k. Alright, so we are almost close to getting what our directional derivative is. So our directional derivative will be a multiplied by grad phi, so which is 1 over root 29 multiplied by 2i plus 3j plus 4k. Okay, so let me confirm, is it plus 4k? Alright, so it's actually minus 4k. I think I've missed the sign here. So it's minus 4k. So if we should have this in bracket as minus 4k all square, it will still be 16. So that didn't affect that. So let me just correct. So this is minus. So with that, this will also be minus. So alright, so take note of that. Alright, so now let's continue. So this is our a, and then the cross product of our delta del file, which is grad. So let's see, this is our grad file, which is 6i plus 9j and then minus 3k. Alright, so just like we did in the other example, 1 over root 29. So for dot product, this 2i will multiply 6i, and that will give us 12. Like I said, if you are multiplying dot product, the coordinates will be out. Then 3j multiplied by 9j, so that will be 27. And then minus 4k multiplied by minus 3k, and that will give us plus 12. Alright, so doing this will give us 1 over root 29 multiplied by, so 12 plus 27 plus another 12, that will give us 51. Okay, so that means we are going to be having 51 divided by root 29. So let's type that in the calculator, and that will give us approximately 9.47. and this right here is the final answer to the question. So that's what you have to get if you were to calculate the directional derivative. So if you solve this initially before you go through the solution, just let me know if you got the answer correctly. So far we've looked at directional derivative, we've looked at 2 examples so far and the application of the examples. So I just hope you got it. If you didn't get it, I would just encourage you to just watch the video all over again, and then you get a proper understanding. So if you have any questions, do not hesitate to leave them in the comment section, and then I'll see you all in the next one. The video still continues on gradients, curl, and divergence. Thank you.